Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I'm the teacher, Miss G, and for today's lesson, we are learning how to graph linear equations, specifically the linear equations that are already in slope-intercept form. There will be a second video on how to turn linear equations that are in standard form into slope-intercept form. This is an important skill to have so that you can use our slope-intercept form in order to identify your slope, identify your y-intercept, and then graph the lines. This video also will go over a little bit about horizontal line equations and what they look like, and vertical line equations and what those look like. So let's get started with our graphing linear equations. The first thing we want to ask is, how do we graph linear equations using the slope-intercept form? To draw a line of a graph, or to graph a line using the slope-intercept form of a linear equation, you will need to know two things. First is the y-intercept point, or the point 0b, where we begin or start our graph. So if you can think B for begin, that sometimes helps students remember that. In your equation, you will just have the B number because this represents a point on this y-axis line. Every single point on this y-axis line here starts with 0 in the x position. So the y value would be the B, for instance. So this point is 0, -1, which means that, you know, the -1 is your y-intercept, and the point 0, -1 is where you're going to make that point on your y-axis. That's going to be where you begin your graph. And then the slope, or the M, is how you move the graph to the next point and the next point and the next point. Another word for slope is rate of change. How do we move on the graph from point to point? So since this linear equation has a -1 for the B, we are going to make that point first, and then 2/3 is our slope. So our slope tells us how to move. And in general, this is how it works. If it is a positive slope, the movement would be this way. The top number means to go up if it's positive. The bottom number goes right. And if it's a negative slope, which we don't have in this equation, but we will have some negative slopes come up. If we have a negative slope, let's say our 2/3 was negative. The only thing that's going to change between a positive 2/3 slope and a negative 2/3 is the top. Instead of going up, you're going to go down, but the bottom still moves towards the right. So to better explain how this works, we're going to show you some examples on the next screen. Actually, the examples are on the following screen. This is just a quick reminder of our positive sloped lines. Whenever you're checking yourself to see if you've graphed a positive sloped line correctly, you would need to make sure that you're reading the line from left to right. And if it's going up from left to right, that means it's positive. If it's going down from left to right, then it's negative. If it's a horizontal line, it's a 0 slope. And if it's vertical, it is undefined. And so in a previous video, we talked about the different types of slopes, and we have the slope guy here, or the slope man, that helps us remember our positive, our negative, our undefined slope, which is his nose, and our horizontal line with the 0 slopes on either side. We also have the slope tree, which could also help you remember the 4 different types of slopes that you're going to come up with. All right, so again, y equals mx plus b is what we call slope-intercept form. The slope is the m. It's always going to be right next to that x. It's always going to be multiplied times the x. And the other number, the constant, is going to be your b, or your y-intercept point. And sometimes, let me show you something here. Sometimes they will try to fool you a little bit. Like this equation here, this y equals 2x plus 3, I could rearrange it. I could say, well, this is the same as y equals 3 plus 2x, because in addition, we have this thing called commutative property, which means we can switch around numbers that we're adding and still get the same answer. So don't be fooled if, it shows up that way for you, because you just have to remember that the x is always being multiplied times the m, or the slope. So even if they move them around, you should still be able to identify which one is the b and which one is your m, or your slope. Okay, so let's keep going. Here is some examples we're going to try. The first one is y equals 3x minus 8. So our m, our slope, is 3, and our b, or y-intercept point, is negative 8. So it's very important that you look at the operator next to the b. If that is a plus, then it's a positive 8. If it's a minus, remember a minus is the same as a plus negative. So you can kind of think of a minus 8 as a negative 8. You don't have to necessarily change it to plus negative every time, but it is helpful to remember that a minus 8 there would be a negative 8b. So where are we beginning our graph? We're going to begin at the b. So again, all lines, unless it's a vertical line, are going to start on this y-axis here. So if we're beginning on the y-axis and it's at negative 8, it's going to be way down here. So we're going to put a little point at negative 8 on this y-axis. Now our slope is how we move. So remember, we begin at the b number and we move with our slope. And so it helps us to remember the variables that represent those two things as well. So we're beginning at the b and we are moving with the slope. Now our slope is actually a ratio. If we turned this whole number 3 into a ratio, it would be 3 over 1. And since it's positive, that means the top number will go up and the bottom number will go right. So starting at your beginning point, we need to move up 3, 1, 2, 3 squares, and 1 to the right and make another point. And we can keep going. 1, 2, 3 up. We're rising up and we're running over 1. We're rising up 3 more and running over 1. And we're rising up 3 more and running over 1. Now you don't have to keep going if you don't want. You only really need 2 points to graph a line. We have several here. So the last step is just to connect your dots with your pen. I'm going to try to do this without making it too crooked. And then draw little arrows on either end of your line to represent that is a line that goes both directions for infinity. Another example is this one here. Let's change colors and do this one in a different color. Let's try red this time. Okay, so this time our m is 4. Actually, it's negative 4. So let me put a little negative in front of there. And then our b is 9. Positive 9. So this time we're going to start or begin our graph way up here on the y-axis at the positive 9. And since our slope is negative this time, it's negative 4. Turning that into a ratio, we place it over 1. And this means we go down on the top number, but the bottom number still goes right. When you're graphing forwards, that bottom number is always going to be moving towards the right. It's really only the top number that changes when you switch from positive slope to negative slope. So we need to go down 4 spaces and right 1. So let's go down 1, 2 from our starting point, our beginning point, our y-intercept point. We're going to go down 4, right 1, make a point, down 4, 1, 2, 3, 4, right 1, make a point. And we'll stop there because we don't really need to keep going. You can keep going if you choose to, but we really only need 2 points to make a line. I'm sorry, my lines are a little crooked, but it's kind of hard to draw with a mouse. All right, so our next one is y equals x minus 5. So let's switch to a blue pen this time. And our slope this time is an invisible 1. There is a 1 here. They will not write the 1 ever. So you just have to know that if there's no number in front of your x, the number is a 1. Could be a -1 if there was a negative in front of that x. But this one just has nothing in front of the x. So that means there's a 1x. And our slope is -5. Sorry, our b, our y-intercept point is -5. So we are beginning at -5 on the y-axis, which is way down here. And since our slope is +1, if I turn it into a ratio, I'm placing it. Now, you only have to place it over 1 if it's not already a fraction. Sometimes it's already a fraction and you don't have to do that. But when it's a whole number like 1 or -4 or 3, you do need to turn them into a ratio by placing them over 1. So this means I go up 1, since it's positive, and to the right 1 on the bottom. So starting at my beginning point, up 1, right 1, make a point. Up 1, right 1, make another point. Up 1, right 1, make another point. I can keep going if I want. I'm just going to stop right here, connect my points. And there is my blue line graphed. All right, so the last one we're going to do is y equals -6x. So let's switch this to an orange. And notice there is no b number. So when you're writing your slope, the slope is, oops, whoa, what just happened there? Hang on. Let me fix that. Mouse decided to go a little nuts on me there. All right, so when we're writing our slope, okay, that time it worked out. That's easy to see. It's always the number next to the x. But when there is no b out here, you have to remember that the b is 0. They will not write a +0 out beside that, because if you add 0 to -6x, it's just -6x. So they're not going to write this +0. You just have to remember that it's there if there's no b there. Okay. That means that that line's proportional because we're starting at the origin. And anytime a line is straight that goes through the origin, it's a proportional line. So our slope is -6. So that means it's -6 over 1 when we turn it into a ratio. That means we need to go down, since it's -6, and to the right 1. So starting at our origin point, we're going down 1, 2, 3, 4, 5, 6, right 1. There's my first point. And then if I go down 6 again, 1, 2, 3, 4, 5, 6, I am off the graph. I would be like way down here. So you don't necessarily need more than 2 points to graph that line. So we're just going to graph these 2 points here and not worry about that third one. All right. So that's basically how you do it, guys. Your B is where you begin, which is on the y-axis, and then your slope is telling you how to move. If it's positive, you're moving up and to the right on the bottom number, and then if it's negative, you're moving down with the top number and right on the bottom number. Okay, let's graph some more linear equations without the use of a calculator. This one is got a slope of 1/4, so we're just going to keep our same orange thing here. And we have 1/4. So this one we don't need to turn into a ratio because it's already a ratio. And our b is -5. Don't forget, when that minus is in front of that, that makes that a negative. Oh, okay. Don't know why this does this sometimes, but it has a mind of its own. My computer sometimes. Okay, so -5. So we're going to begin at the -5, which is way down here. And my slope is positive, which means I need to go up 1 this time and right 4 spaces. So up 1, right 1, 2, 3, 4, make another point. Up 1, right 1, 2, 3, 4, make another point. And that's about all I can do without going off of my graph here. So let's connect our little points, draw our little arrows, and we are done with the orange line. Next one is y equals -2/3 x plus 7. So let's change to a different color here. Whoops, lost my mouse. Okay, we'll go back to, what have I not used yet? I haven't used purple. Let's use purple. Okay, so our our slope is -2/3. So 2. And then my B, or my beginning point, is positive 7. So on my y-axis, I'm going to go all the way up to positive 7. Make a little point there. And since it's negative, the top number goes down 2 and the bottom is going right 3. So we're going to go down 2, right 1, 2, 3, make a point. I can do it again. Down 1, 2, right 1, 2, 3, make another point. I can keep going, but I'm going to stop there and just connect these points together. Draw my little arrows, and I will have my line. All right, this one is y equals negative x plus 5. So negative x plus 5, that's a negative 1x there. Again, if there's no number in front of it, the number is a 1. So our m is negative 1. Our b is positive 5. So we're going to begin at the b again on the y-axis. That would be right here, positive 5. And moving with the m, or the slope, this time my m is negative 1. So that's negative 1 over positive 1 when we turn that into a ratio. That means I go down 1 into the right 1. So down 1, right 1 would be right there. Down another 1, right 1 would be right there. Down another 1, right 1 would be right there. And you can just keep going as long as you want until you run out of graph. That's enough. So we're just going to connect those points, draw our little arrows on either end, and we're done with that. Okay, the last one is another one that does not have a B. That means we have a 0 there. Don't forget, if there's no B, it's a 0. They're never going to write it, but it is there. So this is one of those proportional lines. The number next to the x is our m, so we know that's 3/5, and it's positive 3/5, which means we're going to go up 3 and right 5. That 5 looks like an S. There we go. And then our b, of course, is 0. So this time we are starting at the origin point right in the middle. Oops. Oh my goodness, that point. We're going to go up 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5. There's my next point. We can do it again. Up 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5. And I can connect all of those points and draw my line. Whoa. Okay, well. All right, that was a fail. Let's undo that. I don't know why, but my mouse just does not work right sometimes when I'm trying to graph lines and stuff. Okay, let's try this again. And I don't like the way that point looks either, so we'll redo that one. All right, so it was here. Then we went up 3, right 5, up 3 more, right 1, 2, 3, 4, 5. There we go. Right? 1, 2, 3, 1, 2, 3, 4. Yeah. Okay. All right. It's just going to be crooked. Just going to be crooked. But we'll be okay. All right. So there's quite a lot of examples of how to graph linear equations in slope-intercept form. But what about horizontal and vertical lines? Well, the way you can recognize a horizontal and a vertical line equation is the fact that both variables are not in the equation. For instance, here on the left, you've got a horizontal line. The equation for it is y equals 2. There is no x. So anytime you have a linear equation that is missing either the y or the x, you're going to have to think hoi for horizontal or vux for vertical. And hoi vux is just a mnemonic device to help you remember that horizontal lines have equations that start with y. That's why hoi has the y at the end. Also, all the y values are going to be the same in every point on that line. 0 is the slope of a horizontal line, so that's where the O comes from in the hoi. And then, of course, H just stands for horizontal line. So what this is telling me to do is go to my y-axis, that's this axis here all the way down, right? Find the 2, which is right here, and just draw a horizontal line through that axis. It is not on the axis, it's through the axis. So you're going to the y-axis, finding the 2, drawing a horizontal line through it, and every point on this horizontal line is got a 2 in the y position. For instance, this point here is 0, 2. This point here is 1, 2. This point here is 2, 2. This point here is 3, 2, and so forth. Over here, we've got negative 1, 2, negative 2, 2, negative 3, 2. But as you can see, the y value in all of those points is 2. For horizontal lines over here, you've got x in the equation, but no y. So again, if you're missing one of the variables, x or y, you're not going to have a normal slanted line. You're going to have either vertical or horizontal. So if it's an x, think VUX, because VUX has that x in it. And V stands for vertical. The slope U there stands for undefined, because straight up and down line has an undefined slope. And basically what they're telling you to do in this equation is to go to the x-axis. This is the only type of linear equation we're going to be graphing that starts or begins on the x-axis. All of the other ones start on the y-axis, but this one you go to the -5 on that x-axis, and then you draw a vertical line through the x-axis, and that will give you your vertical line that you're trying to graph. Now, again, every point on this vertical line has a -5 in the x position. So like this point would be -5, 0. This point is -5, 1. This point is -5, 2. This point is -5, 3. All of the x values are the same on every point on this y. Just like on horizontal lines, all the y values were the same. But on vertical lines, all the x values are the same. So hopefully that will help you learn and practice how to, plot or graph horizontal and vertical lines using the Hoy-Vux mnemonic device. All right, let's try some of these. All right, so let's just practice some made up ones. Let's just make up a number. Well, let's say y equals 7. Okay, so I'm going, since it's y and it's Hoy, I know that my slope is 0, but I'm going to go all the way to the 7. I'm going to make a point there. I'm going to draw a line through that 7. Your line should be straighter than mine. It's just a little hard to write on this, but it should be a straight line through there. Vertical, let's do the same thing. Let's see if it's x equals 7. So this time we're going to the x-axis, finding the 7, the positive 7, and drawing a vertical line through it. Let's see, that one turned out better. Okay, and you can practice this with any number. You know, you can use -1, you can use -2, or whatever number you want to try to draw vertical or horizontal lines with. Here's another one. Now this one has not been solved, so let's solve this one. Since there's one variable and it's an x, we know that it's not a normal line. It's going to be a Hoy or a Vux. In this case, it's a Vux. To cancel out our 3 and isolate our x, though, we need to subtract 3. So that means we need to subtract 3 on the other side. This is a one-step equation, and we do need to solve it to get what x is equal to. Once we have that, we will have our vertical line equation, or our Vux. So in this case, we're going to 4 on the x-axis. We're making a point there, and we're drawing a vertical line through it. All right, here's another one that hasn't not been solved yet. So let's change colors. Let's go for orange this time. Okay, this time 8 is being multiplied times the y, and we want the y to stay, but the 8 to go. So let's turn that into a 1. 8 divided by 8 is 1y, which is what we want. We want to isolate our y. And when I divide this by 8, I get -4. And since I don't have an x in this equation at all, I know this is a Hoy, or a horizontal line. So over here, I'm going to go to my y-axis. I'm going to find my -4, and I'm going to draw a horizontal line through it, and that it will be my line for that equation there. All right, so great job, y'all. Remember that the y-intercept point or the point 0b is where you should begin the graph, unless it's a horizontal or vertical line, which in that case, there would only be one variable, either the x or the y, instead of both variables in the equation. Remember that the slope, or m, is the way to move from point to point. The slope ratio is move of the rise, which is the y-axis, over the move of the run, which is the x-axis. Remember that if the linear equation shows y equals mx with no b, that means the y-intercept point is 0, or the origin point, and those are proportional lines. Remember that you can graph in the opposite direction or backwards by reversing the directions of the numerator and the denominator of the slope ratio. And I did not show you guys that, so let's go back here. Let me show you how to do that. Okay, all of these that we graphed earlier, I'm going to take a black marker here and I'm going to show you how to graph them backwards. So our orange line here, if I wanted to go in the opposite direction, because notice on all of these, the bottom number is going right every single time. The bottom number goes right. So when we're graphing forwards, we're always moving towards the right. But if you want to go backwards, you simply change both directions. Like for this one, I went up and right. So to go backwards, I would go down and left. So if I go down 1 and left 1, 2, 3, 4, I would end up there. And as you can see, if I extended this line, it would go in the other direction. Okay, if I wanted to graph this one backwards, I would go up and left. So that means on the purple line, if I go up 2 and left 3, 1, 2, 3, I can extend my line in the opposite direction. That's what I mean by graphing backwards. Sometimes we do have to do this, so it's good that you know how to do it. Let's try this one. We're going to go up instead of down, and then left instead of right. So again, we're going backwards on the blue line, so we need to go up 1, left 1. Up 1, left 1, and it's going to extend that line in the opposite direction if you go in the backwards motion. And then the last one was up and to the right. So to go backwards, we would go down and to the left. So on the red line, I'm going to go down 3, 1, 2, 3, left 5, 1, 2, 3, 4, 5, and that's a point that's going backwards in the opposite direction. Okay, so now that I've gone back and shown you how to graph backwards, we can go back to our remembers. Remember that you can graph in the opposite direction or backwards by reversing the directions of the numerator and denominator of the slope ratio. And also remember that horizontal and vertical lines are graphed differently by finding the x value for vertical lines and the y value for horizontal lines using the mnemonic device Hoy and Vux. So that's it for graphing linear equations. Thank you for paying attention and for working hard. And if this is confusing, maybe you should go back and review the slope video. And then the next one you should probably watch is the converting the slope, converting standard form linear equations into slope intercept form so that we can graph them. And now it's time for me to say it was lovely teaching you math today. Bye-bye.